Today we're going to continue with our similar figures unit. Today we're going to be talking about naming and labeling corresponding parts of similar figures and writing statements showing that two triangles are similar. We're going to first start by looking at how to determine if triangles are similar. We want to be able to, in the end, write a similarity statement based off of the picture that's given. Before I do any answering of angles congruent, sides proportional, or similarity statements and scale factors, let's look at our pictures. We can see that angle A has the same congruent marks as angle D. So therefore, we know that angle A is congruent to angle D. We can also see that angle B is congruent to angle E because it has the same congruent marks. Before looking at the third angle, let's take a look at the fact that the side in between AB and the side in between DE have a proportional length of 10 to 20, which simplifies to 1/2. This is because they share two common angle measures. Now looking at our last angle, angle C is congruent to angle F because they also have the same congruent marks. With that being said, I can then follow through and state that 6 is proportional to 12 and that 7 is proportional to 14 because they share the same angles. Therefore, I know that I have a scale factor of 1/2 because they are all sharing the same proportional value. And I can write a similarity statement by making sure that I go in the same order of each triangle. Triangle ABC is similar to triangle DEF. If I was to go in reverse, meaning starting with the larger triangle and going to the smaller triangle, I would have a scale factor of 2 to 1. So if triangle DEF is similar to triangle ABC, we would have a scale factor of 2 to 1 because we're comparing the large to the small triangle. Now we're going to take a look at another example that's similar but looks a little bit different because I have actual angle measures inside of my triangles. So I need to pay close attention to the actual angle measures. Since angle R is my smallest angle, I know that it is across from my smallest side. Since angle P is the middle angle measure of our triangle, it is across from my middle value of my triangle, which leaves angle Q to be across from the largest side because it is the largest angle. And we can write our corresponding angles over here. Angle R corresponds with angle X. Angle P corresponds with angle D. And angle Q corresponds with angle E. So I can write my statements over here. Angle R is congruent to angle X. Angle P is congruent to angle D. And angle Q is congruent to angle E. Since I know that my angles are across from their corresponding sides, I can write my proportional statements as follows. The smallest side of 3 is across from, is proportional to my smallest side in my second triangle, which is 6, which has a proportional value of 1/2. My next side, which is my middle, is proportional to the middle side of my other triangle, which is 8, which simplifies to 1/2 as well. And my largest side of 5 is proportional to my largest side of 10, which simplifies to 1/2. So therefore, I have a scale factor of 1/2 when comparing my smaller triangle to my larger triangle. And I can write my letters in any order as long as I keep them in the same order with the corresponding angles. So if I start with my smallest angle R, my middle angle P, and my large angle Q, I need to do the same order in the large triangle. So small x, middle D, large E. Now we're going to take a look at a review of what similar triangles creates. It creates proportions that can be set up and solve for any missing side length by using cross multiplication. Let's take a look at some examples that show us how to find missing side lengths of triangles. Let's first notice that we are comparing triangle ABC, which is our big triangle, to triangle DBE, which is our little triangle. So you can see that I wrote a proportion, big triangle to little triangle, which means I need to know the side lengths of my big triangle. That means I need to add together 6 plus 4 to get a side length of 10. I already know that the side length of my other side, BC, is x, because that's what I'm looking for. So I can set up two proportions. AB corresponds with DB, and BC corresponds with BE. And I'm going to fill in my values. AB is 10, DB is 4, BC is x, and BE is 8. I'm going to cross multiply. 4 times x equals 8 times 10. 4x equals 80. Now I'm going to divide both sides by 4 and get that x is equal to 20. And since BC is equal to x, I know that length BC is equal to 20. Our second example is similar triangles, where I'm comparing large triangle ABC to small triangle DBE again. This time I want to find the length of BE. I don't know the entire length of my large side, so I need to fill those in. AB is 12. And in order for me to find BC, I need to add together the x plus the 9. So when I set up my proportion, I have AB compared to DB. That's proportional to BC compared to BE. And I'm going to fill in my values. AB is 12, DB is 4. BC is x plus 9, and BE is x. Since I have two expressions, that just means that I'm going to have to do a little bit more work to solve and bring x to the same side. So we have 12x is equal to 4 times the quantity of x plus 9, making sure that we distribute the 4 to everything inside the parentheses. Now I'm going to subtract 4x from both sides to isolate my x. So I have 8x is equal to 36, and therefore x is 4.5. Well, since x is 4.5, and I know that BE is equal to x, I can say that BE is equal to 4.5. Please pause the screen and try these problems on your own. Now that you've had time to try these problems on your own, I'm going to work through them to make sure that you understand how to solve them. In practice problem number 1, we are solving for the missing value of x. So we need to make sure that we are comparing our big triangle of QSR to our little triangle of FSE and their corresponding sides. So I'm going to write that 12x plus 3 corresponds with 18, big side to little side, and 42 corresponds with 12. I'm going to simplify 42 divided by 12 to make my multiplication a little bit easier. This actually simplifies by dividing by 6, and we have 7 halves. That way when we multiply, 2 times 12x plus 3 and 7 times 18, we're multiplying smaller numbers. To distribute inside my parentheses to get 24x plus 6 is equal to 126. We're going to subtract 6 from both sides and find out that 24x is equal to 120. And now we're going to divide both sides by 24, and we get that x is equal to 5. We have another similar triangle where we're trying to solve for x. Again, we're comparing the large triangle to the smaller triangle. So MK, which is our large side of 6x minus 6, compares to its corresponding small side, which is 12. And then we have LK, which is 40, and it compares to the small side of 10. Again, I'm going to simplify this to 6x minus 6 divided by 12 is equal to 4 over 1, just to make my multiplication the same. I'm going to cross multiply. 6x minus 6 equals 4 times 12. So 6x minus 6 equals 48. I'm going to add 6. 6x equals 54. And therefore x is equal to 9 by dividing by 6. We are now going to solve another example. Triangle ABC is similar to triangle RST. We know that AB is 9, AC is 6, RS is 3, and we want to find the length of RT. I've given you a hint here to draw the picture. So I'm going to draw a picture for each of my triangles. It doesn't matter what your triangles look like as long as you have them labeled appropriately. I know that AB is 9, and I know that AC is 6. I know that RS is 3, and I'm looking for RT, so I'm going to use X as a placeholder. I'm going to set up my proportion, comparing the appropriate sides based off of my similarity statement that is written here. So I know that side AB goes with side RS, and that side AC corresponds with side RT. So I can cross multiply. 9x is equal to 3 times 6. 9x is equal to 18. So therefore x is equal to 2. And since RT is equal to x, I know that RT is equal to 2.